Good afternoon. Thank you for inviting me to this big event, and thank you for coming. My name is Jung-in, and I'm working for City University of Hong Kong. Today, I'm going to talk about implementation of building information modeling for horizontal construction project, for example, civil engineering project. Before starting my presentation, let me first introduce myself. I finished my first master in South Korea about geotechnical engineering, and then I worked for a civil engineering company for actually longer than 6 years. And then I studied my second master and my PhD about construction engineering management at Stanford for specifically focusing on building information modeling and virtual design and construction. And my previous supervisor was Martin Fisher. He is one of the most famous guy in our VDC and building information modeling community. And when I started my PhD, Martin Fisher and I investigated the research opportunity and issues related to implementation of BIM for infrastructure or horizontal construction project. Because at that time, most of research focused on about building information modeling focused on the vertical construction project, like a building construction project. So I carried out several research regarding some implementation of building information modeling. So today I'm going to share my some research experience about that with you. So first, I will share some research experience about large-scale development and tunnel construction and the airport extension project. So have you seen this the curve before? Anybody have seen this curve before? No? Yeah, someone. So actually, this curve, the main idea from this curve is that if we can make or spend more effort in the early project phase to make our decision, this will help us or give us more opportunity to improve our project performance. So let's see how implementation of BIM for the civil or horizontal construction project can contribute to spending the more effort in the early project phase. So let's first take a look at how I implement building information modeling for large-scale development. So large-scale development can include some the site formation project like Kai Tak development or Old Town development. Also, it can include some kind of smart city development. So this kind of project usually include or involve lots of multiple stakeholders. So to make better decision, we have to engage those kind of multiple stakeholders in the beginning of a project. So to do that, we have to consider multiple development scenarios and multiple performance metrics at multiple points in time. And also, we have to do this in an integrated manner. But the problem is that in practice, our delivery method is usually paper-based delivery method cannot give us good opportunity. For example, information is not timely searchable. Also, it's not integrated. So it's the multiple stakeholders sometimes have difficulty understand what planners consider or what planners intended. So one of the ideas is that if we can display development scenarios with multiple performance metrics at over time, that should be improve our communication among different multiple stakeholders. But actually, this is not that easy because our manual process, to follow our manual process, first thing we have to do is from our design, we have to extract some area information for each plot. And then we have to collect that, accumulate that into the different land use, and then using the specific coefficient, finally we can figure out some specific performance metrics. This is just only one the case, just one specific point, one performance metrics for one the development scenario. That means if we want to consider multiple scenarios, multiple performance metrics at multiple points in time, it will be very complicated, and that means it will be time-consuming and also prone to error. So to overcome this challenge, I developed the BIM-based decision support method for master planning of large-scale development. Also developed the development strategy simulator, which I call that DSS. So this method first formalize information about 3D information, so like a building type of building and plot ratio. And also like this method formalize coefficient information using performance metrics and building type and related tasks. Using that information and then generate a 4D model and then analyze multiple performance metrics and then visualize and display the schedule, the development progresses as well as multiple performance metrics at the same time. So I applied this DSS for Qatar Economic Zone project, and first thing I needed to do is develop 3D model. And this is this picture shows a different color in this picture represent the building in different land use. And then I needed to identify what kind of multiple performance metrics a client wants. After like iterative discussion, we figured out 9 performance metrics from different areas: environmental, social, and economical, the classifications. And then based on that performance metrics, I studied and defined a coefficient for the specific performance metrics for different land use. And for example, water demand, I need to figure out four coefficient for logistic and commercial material, manufacturing and commercial custom building. And also for worker needed to figure out worker needed, I need to figure out the coefficient for different the land use. Based on that, this as you can see, this is application result of DSS for QEG development project. As you can see, this is the development progresses. We can see the change of performance metrics. This case, cement demand related to construction factors, and the electricity demand related to operation phase. So multiple stakeholders can understand, even who is not familiar with schedule things, they can easily understand how the development progresses and what kind of metrics they can have at specific point in time. So that means they can have better the communication with different the stakeholders. So that's one thing I want to show. And next thing is using DSS, we also applied the DSS for tunnel construction project in Seattle. And then general contractors actually want to see what the different multiple performance metrics. This case, something different from previous case. They want to see the amount of excavation and concrete, amount of concrete required, and labor, the number of labor required at specific point in time. So after that, they can share these ideas with subcontractors, and they make better decisions. But after that, we have some discussions, and we figured out automated schedule generation considering uncertain ground condition is required. So this is actually dealing with uncertainties in ground condition is a very common problem in a tunnel construction project. So as you can see, this is one example from the tunnel construction in Nepal. So the class 1 is the best, the rank mass class, and class 7 is worst case, worst ground conditions. And so before excavation, that means a prediction of ground condition, there is dominant rank mass class was class 3. But after excavation, the dominant actual rank mass class was class 6. That means there are significant difference, that means significant uncertainties in ground conditions. But even if they have this kind of uncertainties in ground conditions, in practice, planners generate excavation schedule in a deterministic way. Also, planners have difficulty generating schedules based on the up-to-date information about ground condition during construction, even if they can get more information about ground conditions as excavation progresses. So to overcome, and they the construction engineers for the tunnel construction often encounter the problem about cost overruns and schedule delays. So to reduce this cost overruns and schedule delays caused by uncertainties in ground conditions, we figured out what we have to do. So first thing, we have to consider multiple the possible scenarios of ground conditions, and we also consider multiple excavation schedule alternatives, considering the different types of equipment. Also, we have to consider up-to-date information about ground conditions at multiple points in time, because as excavation progresses, we can gather more information about ground conditions by using pace mapping, probe drilling, or something like a tunnel seismic prediction. Actually, there are lots of ways to get more information about ground conditions during construction. But the problem is, if we want to do that, we have to have automated schedule generation and evaluation process. So to make an automated process, formalized the information and process were required. So to overcome this limitation, I developed tunneling schedule generation and evaluation method applicable to pre-construction and construction. So first, in current practice, practitioners usually consider, as I mentioned, only one scenario of ground conditions, but this method can consider multiple possible scenarios of ground conditions. So that means I extended representation of a material in IFC from one-to-one relation to one-to-one to multiple relations. And also after that, this method, in practice, practitioners usually generate several schedule alternatives, but this method can allow generation of multiple, lots of the schedule alternatives. And then finally, this method also allow practitioners to consider evaluate cost and durations for multiple the schedule alternatives, considering multiple possible scenarios of ground conditions. Based on this method, I applied this method to one 6-kilometer tunnel in pre-construction and construction. And just we consider actually 100 the scenarios of ground conditions, and this method generated more than 100 schedule alternatives, and then figured out identified the best schedule considering multiple possible scenarios of ground conditions. So actually this method could generate schedule with 2.2% less total cost than other like existing or current practice could generate. So also we applied this method, the same project, but in construction phase, during construction. And as I mentioned, we collected more information about ground condition during construction, this case by using face mapping information. And then based on using that up-to-date information, we predict 100 possible scenarios of ground condition. And using that, this method also generated more than 100 schedule. Based on that, we evaluate that. We finally identified the best schedule among whole of like more than 100 schedule. And also, this case, this method could generate a schedule with 2.1% less the total cost than existing or current practice could generate. So that means this the method help us to find better performance metrics. And now let's move to how I implemented building information modeling for airport extension or airport improvement project. So there are actually, during operation of the airport, there are lots of construction activities are occurred. So because we need sometime extension or sometime need to improve the airport. So it's common things like, for example, Dublin Airport, Ohio, the international airport. So, but the problem is that during construction, these construction activities often produce construction dust. But the problem is that, especially during the operation and during landing, the construction dust block or reduce the visibility of landing. So we have to have construction dust mitigation. So before actually in advance, and then usually general contractors need to explicitly describe if their dust mitigation plan has been appropriately developed. But in current method, it is really difficult to describe or explicitly describe if the dust mitigation plan is correctly, appropriately developed. So we developed first a defined dust cloud as geometric representation of the extent of dust at a specific density. And then we determined feasible distance considering flight spacing. And then we carried out atmospheric dispersion modeling. And then we identified the extents of dust at specific densities. And then finally, we generated 3D solid to represent dust cloud, considering different weather conditions. And then we, using that 3D solid information, we developed a 4D model. And this one is, this picture shows dust cloud at specific point in time. Also, as you can see, based on that, general contractors identified when or where they have to have dust mitigation plan, and they can easily or explicitly describe their dust mitigation plan to the client, and then they can confirm they are correctly, appropriately develop their dust mitigation plan for the airport construction. So that's all I want to explain today. So I want to wrap it up. I described 3 different types of projects, how to explain how we can implement the building information modeling for the horizontal construction project. And also, this implementation could integrate information and involve multiple stakeholders and metrics. Also, improve communication and consider uncertainties, and also improve performance metrics and automate generation and evaluation of the decision alternatives. So these are future research, actually something ongoing research doing by myself. And so I apply implement building information modeling for building bridge construction. Also, I'm trying to the implement building information modeling, storage carbon. Also, I'm try to integrate the building information modeling with microscopic traffic simulation to make or to develop better intersection plans. So that's all I want to explain today. Thank you for listening. If you have any question, please let me know, okay?